Hello and welcome back to compiler programming. Today I want to work a bit more on the struct support, and in particular I want to allow casting tuples to structs without assigning. So in here, where is it? Yes. So this test, as you can see, we say that P is a point, we assign it to a tuple, and everything works as it should. However, there is not really a way to do this inline, so I can't just cast this to the point, which is not great and something that we should fix. Okay, and once we fix that, it's also going to be, I think it will be an interesting interplay with one of the other features we implemented recently, so I think it's going to be fun. Okay, it should be able to explicitly cast a tuple to a struct type that matches it. Okay, so we have this thing again, right? Let's say that we do 42 here and 0 here, it doesn't matter. And in here we should be able to say something along the lines of S32 x is cast point this, and then we just return x. So this stuff should explode right now, but we should be able to make it work. Hopefully not so difficult. Let's first see that the test is failing. It is indeed failing. We can focus this test so we can only see it in the long output. Yep, great. Expected operator. Doesn't really matter, I think, what that says. For now, we can just go to token handle cast or something. Yes. That seems like what we want. And let's take a look at it. Right, so right now it is explicitly geared towards integers, which is not exactly what we want. I think eventually I want to turn this into an intrinsic and do dispatch that way, but this is sort of not what we're working on right now. So instead, what I want to do is to just move this check down, and then we are gonna be fine. So here we'll have to do a different type of error. I guess the better error would be something like target descriptor, and then actual is value or lazy value descriptor of what's the name of this thing? Expression. That's what I want. So that would be an error. I mean, support saying that this is. We don't actually need to say that it's a cast because it will be visible from the source code of the program. Okay. This happens basically at the end if we don't know what to do with this, and we return 0. Then in here, this is something along these lines. Okay, so if descriptor is integer, great, we do the original logic, and then we say else if target descriptor is descriptor tuple, and No, not target descriptor. Actually, source descriptor. So that would be expression descriptor is tuple, and expression storage tag is storage tag static. What that means is just that we know exactly what the tuple is. Okay, and that is fine. Here, for now, I'll just do an assert, and then we'll figure out how to deal with it later. So assert that target descriptor tag is, it's a struct descriptor tag struct. Okay, if it is a struct, then what do we do? That's a very interesting question, because right now it's sort of, I don't have a concept of a lazy struct literal, in the sense that let me try to explain it better what the issue is. So imagine that this is not 42, but this is some call, right? So right now I don't really have a way to represent that, or do I? Maybe I do. Maybe that is actually fine. So what we will say now, so same value type, or can implicitly move cast. Is there anything here about the tuple? No, so that's a bit of an issue. I will need to deal with that, but for now, let's just ignore the type checking for now and just make that work. So we asserted that this is a struct. Great. Now what we will do is we will create a lazy value, and this would be mass handle tuple cast lazy proc or something. So target descriptor, that's fine. We will allocate the payload. So that would be just payload, because we always need to do that, regardless of whether it's static or not. I mean, it's an interesting question about figuring out if the whole thing can be evaluated statically or not. I'm a bit not sure that's the right way to go about it. So for now, I'm just gonna ignore the compile time evaluation, and we'll do the easy version. So payload is that is not really what they want, although actually that is perfectly fine for a payload in a sense. So I can actually do what was happening here. That was actually fine. We just need to change to tuple casts, or I can dispatch in there as well. That is, let's keep them separate for now, and then I'll figure out if I can merge them later. So if I build this now, this will be unknown, which makes sense. We can find it somewhere here. So let's make that work. That these are the arguments that we need to have. So this stuff, great. Okay, handle table cast. We have a context, we have builder, we know what we want. Okay. So first, how do we do this? Let's say that, well, first of all, we do this stuff just so that we protect ourselves. And then we need to check that we can actually make that cast. Well, it will be checked in assignment anyway. So let's do the following. We say that I need to. I'm just trying to figure out what is the right way to go about checking the types of it, because there is lots of interesting side problems, but I guess I can ignore again most of them for now. We have expected result. Let's get. So I guess we can do the descriptor. So const descriptor star expected descriptor is expected result. Yes, that's exactly what I wanted to do. Great. Now we for now say that we just take this code over here and say that if expected descriptor is not payload target, right? Then that's not okay. In a sense, I guess that's not even an error, because if we get to here, that's already an assertion. Like, we should never have even tried to get to here, I think, if they don't match, because that should be got by whatever is handling the expression, whether it's assignment or operators, whatever. So I think that's correct, but if I get here, I will just make a user error if that is what is expected. For now, assertion is fine. Expected descriptor is this. And if they are the same, then what we can do is we can just straight up assign, I guess. Yeah, that seems all we need to do. So assign. Okay, mass an error, that's fine. So maybe this is sort of all we need to do. Value star. What is it? Result is value from exact expected result. I don't have a generic way to create a value. That is kind of awkward. So yeah, basically I think I want to extract this stuff into a helper function, because that seems like what I want to do a lot. Static inline value star value from expected result. Sorry for that. Okay, we have expected result. That's fine, and we need to have a context and a builder. So execution context, and function builder, right? That's what we need here. And here we'll just say return 0 and panic and reachable. Great. So if it is an exact, then it's very easy. And then if it is not exact, then we do this, I guess. Does that work? Does expected result have source range? No, it does not. Well, that's kinda awkward. Well, I guess we need to pass it down. We need to. And source range is just used to track in source code where it is happening. So if we show an error, it is shown in the right place. Okay, so let's right away maybe do it here. Context, builder, expected results, and source range. So that is like this. And I can now take it and use it in the other place. Perfect. Star result is this. Then we assign to result from what we assign from the from payload expression. Yeah, that seems fine. And we return result, I guess. Now that I think about it, it's sort of awkward that this even returns a value. Oh. Okay, anyhow. So source range here would be expression source range, I guess. Oh, payload expression. Okay, that builds. The big question is, of course, does it actually do what we want it to do? Okay. Expected an operator. All right, I'm writing C here. That is not what is supposed to be written here. So it's supposed to be like this. Type mismatch. Yes, you are correct. What if I do this? Then actually I don't need even to specify the type. So ideally this should work, but we'll know when we'll see it. And look at that. We are able to cast it to a point. Let's maybe verify. What if I don't provide enough values? Does it actually complain? Well, it crashes. I mean, that is a thing, I guess. Struct descriptor. Yeah, but it's actually a problem, a much smaller problem than what I thought it is. We are just missing one of these things. After you force, you need to do an error, and I'm kind of getting tired of doing this kind of stuff, and it's very brittle, so I'm figuring out what would be the better option here. I guess I will go with more C way of returning an error, and then you have to just sort of deal with it. I don't know. Anyhow, that should help us with that crash. Yes. So that is not exactly the best error in the world, but it did catch that we were doing something bad. Okay, so let's run all the tests now to make sure I didn't break anything else. Looks great. And now, so let's say RG episode. Right, so which episode are we on? We are on 175, I guess. So git add, git commit, episode 175, support, casting, explicit casting of tuples to structs. Nice. Okay. So the next thing that I want to do is actually support C style casts. Mm, yeah, I guess you could call them these C style casts. Um, because in a sense that is all that is necessary to implement like typed literals, right? Because that's what it is. But we only will support C style casts for it's not really casts, it's more like C style literals. Yeah, I guess that would be the right terminology for all of that. So should be able to support C style literal syntax. And what I want to do is this. P is going to be point of this, right? And that is pretty nice, I think. That's pretty readable, and in a sense, the cool thing about this is hopefully I can implement all of it in without touching the compiler. Maybe. Let's see. Okay, so that is a point, and we can actually take the old one and say px plus py to make sure we test more stuff. Okay. Again, let's run this test. It will be very upset with us, I think. Yeah, it is pretty upset with that. And the place where we need to deal with this so this is actually a bit awkward now that I'm considering how all of this works. So I can make this work, but then I will have to make this not work. That is an interesting choice. So the way that like you can define and apply function or macro, doesn't matter, that will be called whenever we find something like this. So in here we have a symbol foo and a number literal 42, and this macro is called. So that's great. Um, however, um, I cannot right now say to actually try to resolve this symbol somehow, which is uh, not great. I think I should be able to do that. Um, Not exactly sure what would be the right syntax for that. Maybe I just do an intrinsic that does the lookup, so it accepts a symbol and then it just looks it up, and that might be an option, I guess. Hmm. For now, let's. Okay, for now, I'll just do it in the compiler and then I will think about this stuff later on. So, what we will do is we will go to apply because there is already a special case. And here we say this. If right hand side value descriptor is a tuple, then what? Well, then we will try to call our cast, right? So return token handle cast argview right. I think I might need to split the cast into multiple functions. Well, let's just move this assertion into here, and then it will be much better. So yeah, that's it's a bit awkward how this is done. It doesn't really match all the other functions that I have, all the other intrinsics. I don't know. Okay, I'm just going to do this for now, and then I'll add it to do later on for cleaning this up. Okay, so we have this, right, and then we have heap payload that is mass cast lazy payload, and well, actually no, that doesn't work because we do need to extract the descriptor from it. Okay, fine. We are gonna create a helper, mass cast helper, whatever, and then there will be here a target or target type, and then value star expression. This is what we want. Match type. Right. So that's not exactly what I would like to have. Right, okay. I guess that's what will need to happen. So const descriptor, target descriptor, okay, fine. Fine. Okay. can do mass return, mass cast helper, context, then target descriptor, and then expression, right? And you want a source range. We can give you a source range as well. That's not a problem. Okay. Now that we have a source range, let's pass it in here. Okay. We now have a helper that should be easier to deal with here. So mass cast helper, we need a descriptor that is pretty easy. And we just say that target descriptor is value ensure ensure type, I think, from left hand side. Left hand side value. I guess I need a context. Left hand side value, and we want a source range as well. Expression, we don't know what it is because that's right hand side value. Okay, that does build, but does it blend though? That is the question. Let's try. Okay, that does not seem to do anything. Right hand side value descriptor tuple. I mean, it's missing this, but it should not have problems. Okay, well, let's try to debug this stuff. First of all, are we even arriving in the right place? That is the question. Okay, we do arrive here. Right. So this operates on yeah. So this code, it operates on tokens instead of runtime values. I definitely need to think how to support both, because sometimes you do want to do a match on tokens. That's very useful. But in other cases, you want to resolve those tokens to the expressions they sort of supposed to be. And for that, yeah, I just need to think about it. For now, we can still make it work. That is fine. So instead of this, we should say that this is a square, right? And so the left hand side then supposed to be a type, and we can do value star RHS, or tuple is well, I guess that's value force. Is that what I want? Token our single context and RHS value and typo, and then in here we'll say this thing, but now it can be an assertion instead of a check. Right, something like that. Okay, let's see if that helped or not. Right. Okay, we got inside. Did we get our descriptor? We did not. And that is because yeah, I need to do this, I think, instead. So value type value is this, and then like this. This is the stuff that I was talking about, where in this function I get in tokens as arguments instead of getting in runtime values as arguments. So if I have this, I will get point token as value, not point resolved to the actual type. And this is token per single will do that resolution for us from the token to an actual like variable. But let's see if I'm correct with my assumptions. Yes, that is much better. Now our descriptor is a struct. On the right hand side we do have a tuple, which is perfect, and that means that we should be fine. Let's try to run through. We exited with status code 0. That's always great to see. So that means that our test should have passed. And indeed, it did. Yeah, so it is a bit unfortunate that I had to write this in here instead of being able to write it inside the language itself, inside of the standard library or prelude here. But it gives me a nice sort of food for thought how I want to handle this stuff, and if I need to add some more things to the compiler. But this is pretty cool. I like that now it is possible to define structs inline, and once I implement support for named tuple values, then this is going to be perfect, because you would have stuff that you have in C and many other languages, which is literals and their named fields. And all of this is still kind of sort of constructed from more primitive things in the compiler rather than being sort of specific to how we handle types, which makes me pretty happy. So yeah, this is all I wanted to do for today. Let's rerun all the tests to make sure that everything is still a-okay. It seems to be. So I guess that's it. Thank you very much for watching, and hopefully see you next time.